All right, today we're going to talk about the law of sines, and later on in the week we'll talk about the law of cosines. Now, the law of sines and the law of cosines are used when you have a triangle and you're wanting to solve that triangle for sides or angles, and you don't have a right angle. Now, all of the trig functions that we've learned in the previous 2 weeks, those are used for right triangles. That's why it's called right triangle trig. Okay, but not all triangles are right triangles. So if none of the angles of a triangle is a right angle, then we call that triangle an oblique triangle. In an oblique triangle, what you're going to have is either 3 acute angles or 2 acute angles and 1 obtuse angle. And when you have this type of situation, you can use the law of sines and the law of cosines to solve your triangle. Now, I posted a video for you to watch before this one on identifying triangles, because in this section, the law of sines, you can use 3 types of triangles with the law of sines: angle, angle, side, side, angle, and side, side, angle. Okay, so be sure that you've watched your video first so that you can remember how to identify these 3 situations. Now, in the law of sines, you actually have a ratio. You have the sine of angle A over side A equal to the sine of angle B over side B equal to the sine of angle C over side C. And when we're solving, we'll use 2 at a time. You won't have all 3 of these. So you'll have A and B, or B and C, or A and C. Now, in order to figure out side A and side B and side C, remember they're always going to be across from their respective angles. So angle A will have side A directly across from it. Angle B will have side B directly across from it. And angle C will have side C directly across from it. So when you have the sine of A over A, this is the sine of angle A across from side A. So the sine of A will be over side A, and in the triangle they're across from one another. And remember, again, these are called oblique triangles when you do not have that right angle in the triangle. Okay, so the first thing we're going to talk about is angle, angle, side, and angle, side, angle. These always have one solution. They're easy to do, and we can go from there. Side, side, angle is the one that's going to require us to do a lot of work. So let's look at number 1. Okay, we have here, if you'll notice, 2 consecutive angles followed by a side. So this is angle, angle, side. Okay, we're looking for this side over here. Now, you can label these if you want to. You can do angle A, angle B, angle C. So this would be side A, this would be side B, and this would be side C. Okay, so we're given angle A and we're given angle C. We're wanting to find side A, and we're also given side C. So let's set up our ratio. We don't need B, okay? So we're just going to use A and C. So we'll have the sine of angle A over side A is equal to the sine of angle C over side C. So angle A is 52 degrees. So the sine of 52 degrees over side A, which is what we're looking for, is equal to the sine of angle C, which is 34 degrees, over side C, which is 10. All this is a proportion, 2 equal ratios that we can solve. So do a cross product. We'll have 10 times the sine of 52 degrees is equal to A times the sine of 34 degrees. Okay, so again, do the diagonal, take the whole number and multiply it to the sine. So 10 times the sine of 52 degrees. When you do your other diagonal, take your side and multiply it to your sine of 34 degrees. Now, if I'm going to solve for A, which is a side, okay, I'm looking for a side, I need to get rid of the sine of 34 degrees. So I'm going to divide both sides by the sine of 34 degrees. and I get A is equal to all of this. Well, this, of course, is a precise answer, but it doesn't tell me the length of my side, so I've got to use my calculator, okay? So in my calculator, I'm going to go over here, and I'm going to go to mode, and I'm going to make sure I'm in degree mode because I'm taking the sine of 34 degrees and 52 degrees. Okay, since I am in degree mode, I'm going to go ahead and type in what I have in my calculator. And I'm going to use a parenthesis, and I'm going to do 10 times the sine of 52 degrees. Then I'm going to see I'm multiplying 10 times the sine of 52 degrees. You see how it's in parentheses? And then I'm going to divide it by the sine of 34 degrees. So the sine of 34 degrees. Okay? That way, I'm just using a parenthesis with the multiplication on top just to make sure that my calculator understands that I want it to take the 10 times the sine of 52, that whole thing, and divide it by the sine of 34. Okay? And I'm going to get all of this, okay, a big long decimal, because I'm taking the sine of some arbitrary angle here twice, so it's not going to be pretty. The directions tell us to round to the nearest tenth, so to round to the nearest tenth, I'm going to have 14.1, because 9 will round the 0 up to a 1. Now, since this is a side, okay, x is actually side A, I don't need to put a degree sign or anything there. It didn't give me any type of measurement like feet, meters, yards, whatever, so I can just do A is 14.1. Now, I should have put a squiggly line there because I just rounded, didn't I? So this is an approximate answer. So side A, which is my x, is 14.1. Okay, and you can set these up any way you want to, okay? I did A, B, C in this way. The worksheet does A, B, C in this way. It doesn't matter, okay? You set your triangle up however you want to, and you're going to be just fine. All right, now let's look at number 3. Let's see what we've got. We've got an angle, and a side. So angle, side is what we are given. We're looking for this one right here, okay? So, let's see what we can do here. If we're looking for x, we have this angle and this side, okay? We're looking for this side, so we need this angle. Now, in a triangle, the 3 angles add up to give me 180 degrees. So I can find this third angle by doing 180 minus 64 minus 45, and that will give me my third angle. So 180 minus 64 minus 45 is going to give me 71 degrees for my third angle. Okay, so let's go ahead and fill this in as 71 degrees. So, again, it doesn't matter what's A, B, or C. You can just pick whatever you want to. If you want this to be A, B, C, I'm just changing things up for y'all so you could see how it doesn't matter as long as you always do a cross, okay? So we are given our B's, okay? We've got angle B and we've got side B, and we're looking for C. So we're going to do the sine of B over B is equal to the sine of C over C. All right, so angle B is 64 degrees, so we have the sine of 64 degrees over side B, which is 32, is equal to the sine of angle C, which we found to be 71 degrees, over side C. We don't know what that is. That's what we're actually looking for. Now let's do a cross product, okay? We have C times the sine of 64 degrees is equal to 32 times the sine of 71 degrees. Now, in order to solve for side C, I'm going to have to get rid of whatever's with it, so I'm going to divide both sides by the sine of 64 degrees. Now, again, I'm getting an approximation, so I'm going to squiggle line it. So, in my calculator, I'm going to do parenthesis 32 times the sine of 71 degrees, and then I'm going to divide it by the sine of 64 degrees. Okay, and once again, I get a long decimal, so let's round to the tenths place. That's 1 decimal place, and I'll get 33.7. Now, this is a side length, so I don't have to put a degree sign behind it. And we're gravy, aren't we? Okay. Now, let's look at number 5. Kevin, Adam, and Dan are passing a hockey puck. How far is Kevin from Adam? Okay, so here's Kevin, Adam, and Dan. We're looking for how far is Kevin from Adam. So this is what we're looking for. Notice on this one we have angle, angle, side again. Okay, angle, angle, side. Okay. So let's see what we can do here. We're looking for this side. We're given this angle and this side. So I'm going to have the sine of 86 degrees over 25 is equal to the sine. Well, if I'm looking for this side, I've got to know this angle. So once again, I need to do 180 minus 71 minus 86. 180 minus 71 minus 86 is going to give me 23 degrees. So Dan's angle is 23 degrees. Okay? So now, let's go ahead and do the sine of 23 degrees, and then the side that we're looking for, we'll just call it x. So do your cross product. X times the sine of 86 degrees is equal to 25 times the sine of 23 degrees. Now divide both sides by the sine of 86 degrees. All right, so let's see what we got here. So we're doing 25 times the sine of 23, 25 times the sine of 23, divided by the sine of 86. Okay, and that's going to give us 9.8. Now, this one actually gives us a unit of measure, feet. So x is going to be 9.8 feet. Okay? Now, all three of these triangles actually used angle, angle, side. But look at number 2. This one is going to be angle, angle, side as well. This one right here, that's what I was looking for. Angle, side, angle. Okay, so this one is angle, side, angle. Okay, so that's going to be your other triangle that you're going to use. But same process, okay? So what I want you to do, I did 1, 3, and 5. I want you to do 2, 4, and 6, okay? On the worksheet before you go to the side angle, because that's the one that's going to give you a lot of work. Y'all have a great day.